Hello everyone, thank you very much for your patience waiting for this long since I posted my preview video about infrastructure design using Civil 3D. In this first tutorial, I'm going to show you how to design an embankment dam using Civil 3D. When I say design, please note that all the required dimensions of the dam should be identified using the geotechnical analysis in any of the geotechnical softwares like GeoStudio, in slope stability analysis as well as seepage analysis, and we have to have a safe dimension of the dam based on the provided standard and safety factor values. Similarly, the dam height or the volume of the reservoir should be properly analyzed and determined through hydrological analysis. So we assume here that these two analyses are already done and provided the appropriate dimensions of the dam. The other important point here I have to mention is when we select a dam location, the topography is not the only factor. There are other factors we have to properly consider, like the geology of the area, the strata, the groundwater condition, and maybe if there are also any other environmental related factors which should be properly analyzed. To make this procedure very clear, I will start a new project and start the design from scratch. New project. The first step in creating a new project is to geo-reference the project itself. Here we have a new project. Because of that, there is no datum, there is no projection, and we have to do projection first. The location of the dam which I am going to use in the tutorial is in Ethiopia, so I will use WGS84 UTM datum. So I will use that one. And again, the location of the dam is in zone 37 north. You have to also fix that here. And I will leave everything as it is. Apply. Okay. Now my new project is geo-referenced. Let's save it. Let's save it with a tutorial one, with the name of tutorial 1. I'm going to replace it. Yes. Now our project is saved. After geo-referencing, we need a baseline for our design. That baseline is going to be our existing ground surface model. Civil 3D provides different methods to create a surface model. It is possible to create a surface model, an empty surface model, and add contour lines as break lines, but in this case we are going to use creating a surface from GIS data. So what we are going to create is a surface, and let's name it as EG, existing ground. This is a display style. Let's keep it as it is and everything as it is. Next. We already created a contour map and saved in shape file format in a GIS environment. We are going to import that shape file so that we can use it to create our surface model. That is our shape file. We have to log in, check this one, leave everything as it is. Next, specify the parameter for the contour map, which is already created previously. Finish. Civil 3D is creating our surface. Okay, our surface is already created. This is our surface for our dam location. Our dam location is going to be around this. According to my previous assessment, this is going to be one of the appropriate location for dam in terms of topography. Of course, in terms of geology, hydrology, it should be properly analyzed. Let's see how our surface model looks like in object viewer. In isometric view, where yeah, it's going to be okay. To visualize the elevation values of these contours, let me label them. This is my proposed dam location, so the minimum value is 1010 meter above sea level, and the maximum continues, but as per my previous assessment, an appropriate dam crest level could be 1170. So I will mark that point. Let's mark this point. Let's put it this way, this direction. It's marked. Here also 1170. This one. Let's mark also this side. So these 2 points are the starting point of the dam and the end point of the dam crest. This is assumed. It could be adjusted later because Civil 3D is dynamic. If you change the alignment, everything can also be recomputed. So as much as possible, our dam axis could be perpendicular to the streamline center line or the stream center line. Okay, now let's create polyline. This is a proposed dam axis. Let's use this polyline to create our alignment. Create alignments from objects. Select. I want to read it from left, right, so reverse. Sorry, reverse it. Let's call it dam alignment. Let's put major and minor label. Keep everything as it is. Okay. Our dam starts from this location at crest level and ends at this location. Maybe it could be good to shift it a little bit this direction so that more of perpendicular to streamline. Yeah. This is our dam alignment. Next to that, we will create our profile using the dam alignment and the existing ground surface. Add it here. Draw. Name it dam profile or dam location profile. Next, leaving everything as it is because we need the profile throughout the dam axis. Great. Let's put it here. Here is our profile. Next step, profile creation tool, the same profile, dam crest. We can put any description. For the time being, I don't want to write anything. Okay. Our dam is going to be a straight line, just a linear dam. This is going to be our dam crest level at 1170, and space is going to be at 1010, around here. Of course, a little bit higher than 1010 in this case, maybe since we shifted the alignment. Our profile is created. It is good always to save our project. The next step is going to be creating the corridor. But to create our corridor, first we have to create an assembly. Dam assembly. Leave everything as it is. Okay, let's put it here. Our subassembly which we are going to use is custom-made subassembly which I created in subassembly composer of Civil 3D, which is named as dam with TOW filter. That one. This. We can adjust the different parameters here. Depth factor of core. It is the depth of the core below the crest of the dam. For example, it is a function of the total depth of the dam from the crest to the base. If we increase this to 0.05, the depth of the core will increase. So it's as a function of the height of the dam. When the height reduces, we can vary the depth of the core based on this factor. Let's keep it as 0.02. Cutoff depth factor again here, that is this depth, which is a function of the top width of the cutoff. If we, for example, make it 3, it will definitely go down. Yes. So we keep it 2. Apply. Depth of foundation is from the base of the dam to the foundation excavation location, this one. If we vary, it's also going to vary. For example, here we can have such a depth of excavation depending on the characteristics of the topsoil on the dam sites. In our case, let's keep it to 2. Dam crest width from the center to the edge of the external shell. So in this manner, there are so many other variables which we can specify them according to the analysis result of GeoStudio or any other geotechnical software which makes the dam safe from sliding, overturning, and also seepage failure. Apply. We are going to use this subassembly with its defined parameters to create our corridor. Our dam corridor. Dam corridor. We can write any description. We come here and specify our alignment. Our alignment is dam. Our profile is the dam crest. Our assembly is also the dam. We don't need any feature line to add. We have to specify also the target surface. Okay. Here we have to specify again the frequency of the sections or the corridor development. Let's put it 10. We don't have any curvature, but just for the sake of consistency, we can also keep it as 10 and apply, rebuild. Now our dam corridor will be generated. Yes. So this is our dam corridor. We can visualize it in object viewer. There is something wrong here. We have to correct this. It is in most cases when the alignment does not really cross the exactly cross the contour line, either in the alignment or it can also be in the profile. For example, if we check this, it is crossing. Actually, it is at the end point, so this is our end point. Yeah, see, this is the problem. So we have to put it here now. It will be corrected. We build up. We can review. Yeah, now it is perfect. We will see what these are in the coming video when we create our surface for different components of the dam. Don't miss the next video once it is created and posted. So this is the cutoff, and this is the external shell, the intermediate zone, and the core of the dam, which is again dynamic, and when the dimensions vary, this also automatically varies. We have done our first tutorial. I hope you enjoyed the procedure. If you have any comment, you can give it to me and I can respond to your comments. This video, to summarize, in this video, we started our design from scratch by geo-referencing our new project, importing a contour map which was saved in shapefile in a GIS environment, and using that we created our surface model of the existing ground. We defined our dam axis, the location of our dam, and that axis is used as our alignment. We created our alignment. Based on the alignment, we created our profile and we fixed the crest level of the dam. We used our custom-made subassembly and created an assembly for our dam. Using this subassembly and the alignment as well as the profile, we created our dam corridor and checked whether it is okay or not. So we conclude our first tutorial at this stage, and we will continue the dam surface creation and material computation in the next video. See you then. Thank you.